Hi folks, welcome to the second part of the 7.6 video in which we're looking at double integrals over rectangular regions. And in this part, we're going to take a look at two specific applications of it. The first one is going to be average value, and the second one will be volume. And they're very similar to the idea of what we did in the previous video, where we're going to use those techniques, but actually show like what they might mean in a different situation. Okay, so let's take a look at this first one. The average value over rectangular regions. Okay, the average value is just looking for sort of the height of this shape. Okay, but most often you'll see pretty spelled out for you. The question will say, I want you to find the average value. Okay, and if we think about like averages in general, you usually divide by like how many things you have. And so in this case, we see something that looks very familiar, that double integral, but then we're sort of dividing by like our change in x values and our change in y values, okay? So the b minus a, these are like your x values, okay? And this d minus c, those are your y values. Okay. And so the process is going to be really similar to what we did before. We're just going to need to remember to multiply by this 1 over business at the end. Okay. So let's take a look at an example. The intelligence quotient Q for a person with mental age X and chronological age Y. So like mental age is like, your brain, but then your chronological age is like, when were you born? How many years ago? Okay. So it's given by this function Q of XY equals 100 times X over Y. Okay. In a group of sixth graders, the mental age varies between 8 and 16. So let me actually do a little bit of color coding before we get too far. The mental age is our X, and that varies between 8 and 16 years. Sure looks like someone's giving us like an 8 and 16 for our integral bounds, okay? And the chronological age varies between 10 and 12 years. And remember, our chronological age is our y values. So, what is the average intelligence quotient for this group? See, it says right there, average, okay? The average intelligence quotient, they're telling you, we want you to use that average value formula. And you still have to do a lot of work. You got to do this double integral. And at the end, you have to remember to multiply by this fraction, but it's not otherwise different from the work we saw in our previous video. Okay? So let's do this. Okay. Now I'm going to start by figuring out just this part. And at the end, we'll go ahead and multiply in the part that makes it the average. Okay? So let's set up our two options. Let me write that in. Option 1, option 2. Are we doing our dy on the outside and then our dx, or are we doing it the other way around? Okay, so the integral of y equals 10 to y equals 12. The integral of x equals 8 and x equals 16. Whoa, 16 of 100x over y dx dy. That's my option number 1. Or option number 2 is we have the dy on the inside and the dx on the outside, okay? So integral of x equals 8 to x equals 16, integral of y equals 10 to y equals 12 of 100 x over y times dy dx. All right, now there's a ton of built-in practice for you here because again, I'm going to do one of these options, and I'm going to leave the second one for you to do if you want the extra practice, so you'll know what answer you're supposed to match, okay? We're going to go ahead and do option number 1, right? And so option number 1 means I have to treat x like a variable first. But that also means that 100 over y, that's a constant, and I can go ahead and pull that out to the front of the x integral. In other words, I have the integral from y equals 10 to y equals 12 of, let me write that better, y equals 12, and I want 100 over y, the integral of x equals 8 to x equals 16 of x dx, and then dy. And again, this kind of goes back to the beginning of the last video where I was like, go ahead and pull out those constants. If it makes it easier for your brain, why not? Okay. So we have the integral from y equals 10 to y equals 12. We get 100 over y times x squared over 2. I'm going to plug in 16 for x, and I'm going to plug in 8 for x. Okay. I'm going to clean this up a little bit before I plug in my numbers. 50 is 100 divided by 2, okay? And so it's just nice to clean things up as we go. That way we don't get stuck with like so many unsimplified things at the end. But the cool thing is this 50, I can actually pull out to the front of the other integral, okay? So I'm going to have 50, the integral from y equals 10 to y equals 12. And then I'm going to plug in my 16. So I get, I get 16 squared over y minus 8 squared over y dy. Okay. Now these are going to be big numbers, and that's okay. And I get 50, the integral of y equals 10 to y equals 12. Let's see, 16 squared, what is that? Let's find out. 16 times 16 gives us 256 over y, minus 8 times 8 gives us 64 over y. Okay, now be careful here. We cannot just subtract these fractions, or can we? Right? This is a good question to ask yourself. Like, when is it okay to use fraction, like combined fractions? And I think it depends on what the operator is in between. So in this case, I have a subtraction and I have a common denominator. So I can go ahead and combine those into a single fraction, okay? So 256 minus 64 gives me 50 times y equals 10, y equals 12 of 192 over y. Okay. So this is what I mean by like always try and simplify if you can, because it makes the next step a little bit easier. All right. Now I can pull this 192 out to the front, and I know the integral of 1 over y is the natural log of y. So let's do two things at once. I've got the 50 times the 192, which is 9600, natural log of the absolute value of y, and I'm going to plug in 12, and I'm going to plug in 10, okay? So I get 9600 natural log of 12 minus 9600 natural log of 10, okay? Now keep in mind, even though we've done so much work, this is not our final answer. The reason it's not our final answer is because I'm asking for the average intelligence quotient, which means I need to go ahead and find this 1 over b minus a times d minus, or 1 over b minus a times d minus c, okay? So let's do that. 1 over, let's see, b minus a is 16 minus 8. D minus C is 12 minus 10, and times this 9,600 natural log 12 minus 9,600 natural log 10. And I'm going to dump that all into the calculator, and I'm going to round to 2 decimal places, okay? And when I do that, I get 1352.79. And this is the average intelligence quotient for this particular group. Okay, so let me get that question all on one page for you. But again, it's very similar to what we did in the first video, but there's the added part of knowing it's the average value that we're asking for here. Okay. All right, let's take a look at one more example today, and this will bring us to the end of our 7.6. All right. All right, so 7.6, last application here. We're talking about volume and double integrals, okay? So it turns out that when we find this double integral, what we're actually finding is the volume underneath a surface, okay? So let's kind of take a look at this question here. I really like this question because I think it provides a really nice diagram of like what we're trying to find. But just like the word average value kind of triggers us to think, oh, we need a double integral, when we're saying volume, we're also thinking we need to set up a double integral, okay? So example 6 says, find the volume of the solid under the graph, f of x equals 1 plus x squared plus y squared, over the rectangle from 0 to 1 for x and 0 to 1 for y. Okay, so if you graph this 1 plus x squared plus y squared, it's this cool shape that we call an elliptic paraboloid. Kind of looks like a bowl. And this bowl is just a little bit lifted up in space. And so if we find the volume, we're finding the volume of like this region here. Okay, so there's like a bit of space underneath this bowl, and we're trying to find out the volume of that space. All right. Well, as long as we can make that connection, it's not even that important that we can see it. It's more important that we know how to set up our double integral. Okay, so just like before, we've got an option 1 and an option 2. All right, option 1, let's put the y's on the outside and the x's on the inside. So y equals 0 to y equals 1, x equals 0 to x equals 1 of 1 plus x squared plus y squared dx dy. And I don't have a ton of horizontal space this time, so I'm going to put option 2 right below it. Integral from x equals 0 to x equals 1. Integral of y equals 0 to y equals 1 of 1 plus x squared plus y squared dy dx. Okay. Now again, like all the other problems in here, I'm going to choose to do one of these, and I'm going to allow you to go back and do the other one so you already know what answer you're trying to match. Okay. I feel like I've been doing option 1 a lot, so I'm going to do option 2 this time. All right. All right, integral from x equals 0 to x equals 1. I'm going to integrate this, but I'm treating y like a variable. So the integral of 1 is y plus x squared y, okay, because x is a constant, plus the integral of y squared is y cubed over 3, and I'm going to plug in 1 for y, and then I'm going to plug in 0 for y. I'm going to be super careful about my signs, and I'm going to subtract them. Okay, integral equals x to 0, x is 1. All right, what do I get? 1 plus x squared plus 1/3 minus 0 plus 0 plus 0. Well, that's really nice. The whole last term goes to 0. And I'm going to combine my like terms here. So I get the integral of x equals 0 to x equals 1 of 4/3 plus x squared dx. That's actually not so bad, right? Like, I know this looks complicated at the setup, and I know we're not done yet, but like it looks complicated at the setup because it's a double integral, but the actual pieces that I'm integrating are not that bad. And now I see a question that only requires me to use power rule, and that's kind of nice. So I get 4/3 x plus x cubed over 3. I'm going to plug in 1, and I'm going to plug in 0. And I get 4/3 plus 1/3 minus, it's going to become 0, so that's okay. And 4/3 plus 1/3 is 5/3. And so what this 5/3 means is this volume underneath the bowl has 5/3 like unit cubed amount of space. All right. All right. So let's get that all on one page for you. I think this is a very reasonable one for you to do both ways. So go ahead and try option 1, see if you can't match that answer of 5/3, and let me know if you have any questions. All right. See you soon.